Well, what do we have here? Oh, yes, of course, it's the Earth. Yeah, there's the north, there's the south, and the equator's right there in the middle. Okay, now this picture looks a little bit different than pictures I'm used to seeing. It was actually made with two satellites orbiting the Earth. They take pictures every 10 seconds and put that information together to see how the air moves around the world. Why is that air moving at all? Well, that has to do with the uneven heating of the sun's light hitting the Earth. Some areas are colder than others, and that's enough to get things moving and creating beautiful patterns in the atmosphere. Let's zoom in on one of those air patterns in the northern hemisphere. Over the Pacific Ocean, you can see this green blob, which represents clouds. And over here, that's us in Portland, where the wind speed is only 2 kilometers an hour. But take a look at that swirling spiral. All those lines are close together. That means that the wind is going pretty fast. Here, it's going 48 kilometers an hour, much faster than in Portland. Now, focus your attention on the direction of the spiral. We call this a counterclockwise motion because it moves in the opposite direction of a clock you might find in a classroom. The swirling counterclockwise motion of the air usually indicates high winds and rain in the northern hemisphere. As we pull back and hover over the North Pole, try to identify all the counterclockwise moving storms in the Northern Hemisphere. All these air masses are called low pressure systems and usually bring bad weather. Let's take a look at the Southern Hemisphere and see if we can find any of those low pressure systems. Now remember, low pressure systems in the Northern Hemisphere are going to be going counterclockwise. Will they do the same in the Southern Hemisphere? Once again, you can see those lines bunched up together, which indicates strong winds. And those green blobs, lots of clouds and rain. So we found our low-pressure stormy system, but take a close look. These storms are going in a clockwise motion, the opposite of the northern hemisphere. These still are low-pressure systems, and they bring the same type of weather, only they move in a different direction. But how can that be? Why does the exact same low-pressure system storm move in one direction in the north, but the opposite in the south? The reason has been given the name the Coriolis Effect. And in the next video, we will examine how this Coriolis Effect can create such beautiful patterns in our atmosphere. To see this website for yourself, go to earth.nullschool.net.